So everyone has done the assignment 3 or wait for 5 minutes. Okay, so we can start now. Okay, let me share the screen. Okay. Okay, so we will do some questions regarding the assignment number 3, and we will discuss some of the methods of root finding that you have already learned in your lectures, I think. So we will see that, and we will do some practice questions as well. Okay, so first one, to find the root. Am I audible, everyone?
Yes, sir, you are audible.
Okay.
Sir, one small query before you start.
Yeah,
With
yeah,
respect
yeah.
to,
If you have any queries, just let me know once. Yeah.
yeah, this is with respect to last assignment question. There was one problem where we are finding the root for a quadratic equation with a
Okay.
minimum and maximum root. I understand that that reply also it came like we have to round it to that nearest arithmetic.
Mm-hmm.
Yeah, when we are rounding, that
Let
is
me
like a
open my camera just maybe. Wait a second. Better to use cameras. Okay, tell me.
so this is like problem number 6.
Problem number 6. Oh, so you have problem in your assignment question?
Yeah, I know. Just want to clarify. The by calculation and calculation, I got some
Wait a
answer, but
second.
yeah,
Just I don't have any means I don't have any assignment in hand. Uh, Wait a second. Maybe I have some solutions. So grading has been done for the assignment too?
yes, yes, it is over.
Okay. Wait a second. Problem number 6. You were having
Yeah,
some issues. Okay, what's the problem?
that is we are having. Yeah, we have to find the largest root for that equations x square minus 90x plus 1 equal to 0.
Mm-hmm.
So when we that is a rounding to 4-digit arithmetic, right?
Yeah.
So when we are finding the root, the largest is 89.9 like 48, and the lowest is 0.0 like 4 ones.
Okay.
So 89.988 when we round it in the fourth digit,
Mm.
still the answer may not be 90, but the accepted answer is 90. Just want to know.
Okay. So you are saying that you want to round off 89.98
Yeah, yeah.
up to 2 decimal places, is it?
No, it is like rounding is like 4-digit arithmetic is what it was told.
Okay.
Find the largest root for the equation, quadratic equation
Mm.
using
Mm.
4-digit rounding arithmetic. That is the question.
Okay. So you're saying 4-digit rounding arithmetic and okay. It's just all right. A second. I just admit one. Okay, so you have founded the root to be 89.98, right?
Yeah,
And
89.98.
it's a 4-digit rounding arithmetic you are getting. Is it?
Yeah, so even you round it in the fourth digit, so it
Rounded
will
till
not
the
be
4 decimal places, right?
yeah, 4 decimal places, it will not be 90. So the answer, whatever
Ah,
it is given as 90.
okay, so yeah, it's a problem maybe. So they have rounded to like, okay, so they have not rounded. Okay, maybe there is some issue. So what are the options? Other options?
Other option is 0.011, that is the lowest root. So the question is for
Okay,
the larger root, and
yeah,
the last one is none of this.
okay, none of these. So you have taken none of these.
Yeah, actually, no, I have selected for 89.98, but I just want to confirm which one is correct. The answer given is 90.
Yeah, so. Hmm. 89.98, they just round off to 90, I think, but it's not right. But it should be, answer should be like 89.98 as such.
Yeah, yeah, and
But they
one
have
more.
not given that option, so yeah, it's ideally it should be none of these, but okay, so maybe, so you have ticked none of these, no?
No,
I
I went for 89.98, but the answer is still, it was not both. It
uh,
was like 90.
okay, I will rectify this. Maybe if someone has ticked that, none of these, so it will be
Yeah,
not counted. Maybe for grading. I will make them sure this thing.
yeah, yeah. I have raised this in the
Okay,
our
I note
forum
down.
also. Yeah,
Can you
yeah.
email me, Shravan, this
Yeah,
question?
yes, I will do that definitely. Uh, just I think I'm having your direct ID. Last time I could not
Yeah.
note properly. That also I can note it now itself.
Okay. So actually, these are not made by me, as someone made that these
I
questions.
got
I
it. I
don't
got
know.
it. No, I got it. I got it. No issue. And there was one more query also, like one
Yeah.
more problem. That is problem number 2.
Mm-hmm. Mm.
Problem number 2. Actually, it is like the answer whatever we are getting is point triple seven into 10 power 1 point
Okay.
or 47 in 475 into 10 power 1
Wait a
475 into
second.
10
What is
power
the
1.
so the question number two says that 75.8125 to binary decimal. Is it?
1 second, sir. Actually, assignment to problem 2. Okay, I think I'm for me the question number is the different. 1 second, sir. I will just open that.
Is it normalized form or something?
Sir,
Okay.
I will just, yeah, I got it. This is for the, again, it is with respect to the relative error. Like there is one rounding arithmetic to evaluate f as point 2 with f of x equal to x sin x plus 2x.
Wait a second. This is the
Yeah,
assignment one, right?
yeah. This is number 8 for me. Sorry, it is not 2, number 8. Problem
Yes,
number
yes,
8.
yes. And what's
Yeah.
the problem in it?
It was like when we are finding this relative error,
Hmm.
with these two, the calculated value is 0.777. So the 7015, whatever it is given in the list, is not at all not coming.
Is it the relative error or they are finding absolute error?
Relative error only. So actually, whatever now the given value.
So the question says to find the relative error or absolute
Yeah,
error.
yeah, it's a relative error. Yeah.
Okay, and okay, so I think that was there is some mistake maybe in some question in the option. I think they are finding absolute error, but in question it is given relative error. Is it that case? Have you find
Yeah,
absolute error?
no, absolute error. I didn't check, but only relative error only. Whatever we
Yeah,
are
I have
getting.
solutions. I have solutions of that assignment, I think. So they have written absolute error
Okay, okay, okay.
in solutions, but I don't know in question what they have written.
Yeah, question it is relative error, sir. Question they asked for a
Okay.
relative error.
So you just
Okay,
write
answer.
in these two questions in email and just let me know.
Yeah. Anyway, I
I will.
selected for one of these only option
Hmm.
for this one.
Okay.
Yeah. Okay, sir.
So
Then
you
I will
got the
try.
marks for it?
Yeah, already it is. I know for this questions it was not awarded. Others it is there.
Okay. 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 Just let me know these two questions. And if you have
Sure,
any
sure.
query like other questions, you can also forward to my mail. I will forward it.
Fine, fine, sir. Please post your. Last time I could not note your email ID, sir. Please post in chat box. I will straight away note it.
Okay. This is my email. You can see. Is it fine?
Yeah, yeah. I got it. Yeah. Thank you. Thank you.
Okay. Yeah. Now I can start. Stop the camera. Okay. So where we were. Yeah. So, okay. So have you learned how to find the roots using bisection method so far in the lectures? or should I recall it first?
But it will be better if you can just explain once.
Okay. So I have a book opened here. I can just explain it using it. Wait a second. Hey, do you have this book? This is a good book actually. Can
So this title, sir, numerical analysis, sir.
Applied Numerical Analysis by Wheatley, Gerald and Wheatley.
Okay.
So, yeah, bisection method is basically easy to understand and it's not a tough to check it. So what we do in bisection, if we have to, okay, I just use the pen. If we have to determine a root of function f of x, say if we have equation f of x equals 0 and we have to find the value of x basically, which solves this equation, then we use bisection method. If it is straightforward, then we don't use any numerical method. But if it is a non-linear equation and it's quite a complicated equation, then you need to use some numerical methods which give like best closest approximation to the real roots. So here is the one initial basic approach, basic method is bisection. This is the first method that we study to find the roots. So what we do in bisection method is that we just take any two arbitrary points, x1 and x2, any points x1 and x2 on in the real line, and we just try to check the function values fx1, f at x1, and f at x2. And if the product of these two function values is less than 0, right, then we guarantee that there exists a root between them. Okay, so how do we guarantee? Do you know this? So if we have x1, x2, and the function is like what does this expression means? F of x1 into f of x2 is less than 0. It means that either the function at x1, function value at x1 is positive, or a function value at x2 is positive, but not at the same time, right? So it may be positive at this or it may be negative at this. So what guarantees that there exists a root between x1 and x2 is given by intermediate value property. You know that. So we have to assume that here f should be continuous, right? So in that case, intermediate value property holds, and which says that there exists a root between at some point c such that f of c is 0. But the bisection method doesn't give actually that root, but still find a closest approximation. How does it do this? So if you are sure that f of x1 and into f of x2 is less than 0, then you take x3 to be x1 plus x2 by 2, and you just check if f of x3 is into f of x1 is less than 0, then there exists a root between, uh, x1 and c, which is x3. See, I just don't take x3 as such. So x3. So if f of x1 into f of x3 is less than 0, then there exists a root between any of them, or either it lies in this interval. Like this. Like this, you approach to the root. Like this, you need to continue the steps until you reach you reach very close to the root, but not exactly the root, maybe. So you need to specify some tolerance level, like some error bound between the last two iterations that they have described here, like difference between x1 and x2 should be less than some tolerance value. Difference between first iteration and second iteration, maybe this. So this is a good method, but it may not work if your function is not continuous. It's not continuous, then it may not work because the intermediate value property may not hold, right? Okay, so we try to do this question here. Okay, so in this question, to find the root of f of x equals 0, what do you use? You have to use the bisection method. At the beginning of an iteration, lower and upper guesses of the root are xl and xu. Okay, so what is the value of x1 and x2 here? It's xl and
It's
xu, right?
XL and XU, yeah.
Yeah, so they have given just two arbitrary numbers to us, XL and XU. Is it working? Yeah, XL, XU is X1, X2. Okay. Then you, at the end of the iteration, the absolute relative approximation error in the estimated value of root would be. So what should be the next closest approximation to the root? What should be that value in the bisection method? Okay, I can write on this one here.
X1 XL plus XU by 2.
Okay, so x1 is XU XL and x2 is XU. Yeah, what is the next one? X3 should be x1 plus x2 by 2, which is XL plus XU by 2. Okay. And what is the, so this is what the bisection method says, that after first iteration, this should be the actual value of the root. Okay. So bisection from bisection method. In this case, we say the value, actual value is basically the value coming from bisection method after first iteration, and approximate values are like XL and XU that we were having an initial guess. So which we say X actual is just after first iteration. Okay. XL plus XU by 2. Okay. So this is XL, X actual. And how do you find the relative error? Do you know that? This is XL or X. So what should be the other question says? What the question says? You need to find the relative approximation, absolute relative approximation error. How do you find it? Anyone?
Approximate minus actual divided by actual.
Yeah. So actual. So what is the value? Can you tell me? So what is XU minus XL or XU? You can take anything. Okay. So what should be this? 2XU. Okay. So what should be the answer? Is it fine? It's easy, right?
It can be other way also, like XL minus XU also. Like if you are taking,
Yeah. What you are saying? XL. X
yeah, if you are
approximate should be
taking,
X.
yeah, XL,
Yeah,
if I am
answer will be
taking,
same.
yeah,
Answer will be same.
okay, sir. No, otherwise also since mod is there, if I am taking minus out,
Ah, that's
ulta,
right.
the other side also is correct.
Hmm. Okay. So bisection method is not a difficult task for you, I think. Okay. So maybe we can search for any question which resembles bisection method first. Okay, second one is also based on bisection method. Assume an initial bracket of this. The second iterative value of root using bisection method is. So you try to solve it with me. That would be good. Okay. So here t to the power minus t minus 0.3. So what is ft is equal to 0, the equation? Okay. So what is the bracket initially? It is, so we have x1 to be 1 and x2 to be 5. Okay. Now you check. Now you check the value of f at x1, f at 1. What is the value at 1? Tell me. You calculate it. You have to calculate. I wait.
0.067879.
Okay.
Inverse of it minus
0.06. What is
seven
the
eight
value?
7879.
Is it?
Yeah, that is
Okay.
inverse of e minus 0.3.
Yeah. So it is greater than 0, right?
Yeah,
And what about f5? What is this value? f2 fixed. Solve it. Have you found out?
this is minus 0.2663.
Minus
Point
point
26631.
31.
Yeah, 31.
Is it
31 or
correct?
310. Yeah, 310.
Anyway, whatever. But it should be positive or negative. It
It
is
is not
negative. Okay.
negative. Yeah.
Okay. So what guarantees now? It's just f of x1 into f of x2 is less than 0, right?
Yeah.
So by intermediate value property, you have a guarantee existence of root. Okay. So x3 should be x1 plus x2 by 2. What is this value? It should be 3, right? Okay, so what is the now you want what you want to check? What you will check? Okay, so let's see what the question. Second iterative value of root. Okay, so we have found out the okay, second iterative value of root. So it is the second one or first one? It's the first one, right?
First one. First one.
First iteration. And what about the second one? How do you find out? So f of x1, f of x3. Just check whether it is less than 0 or f of x1, f of x3 is greater than 0. Which one is true? Oh, sorry, I just written again. See, my check which one is true. What is f of x3? Just tell me this way. What is the value of this? And take the products of two and tell me which one I should go.
f of x3 is minus 0.150638.
Okay.
So x1 into x3 is 0, sorry, less than 0.
Okay.
And the f2 into f3, sorry,
Yeah.
x2 into x3 will not be, because that is minus, this is also minus. That will be
So
positive.
what guarantees the existence of root? In which interval I should go? X1, X3 or X2, X3?
It should be between x1 and x3,
Yeah.
because x1 is positive, x3
Yes,
is
yes.
negative, means it is in between these two.
Mm-hmm. So what should be the value of, okay, maybe I think X4 is X1 plus X3 by 2. So what is this value now?
1 plus 3 by 2, that is 2 again.
Okay, so is there any option 2? Okay. So I think it's the right one. Which is the right one? The 2 is the right one, right?
Yeah.
Initial
Up to
bracket, the
second
second
iteration
iterative.
is, yeah, we have to complete up to second iteration. So finally, we have to
Yes.
find that f2 also, sir, f of 2 also, or f of x4 also, we have to find the value, or we have to limit with f of
No, it's
x.
just, yeah, it's done. It's second iteration.
So f of x3 is the final answer.
Yes. Yes.
Okay.
F of x3, or they are just finding the value of root, right? They are
Okay, we have,
saying that the second iterative value of root, not the function value at root.
okay. Got it. Clear. Okay.
But it
Sorry.
should be like the function value should be closer and closer to 0 as you proceed, because it's
Correct.
the root.
Correct.
Okay. The second is done. What about the third one? Third, we should not go, I think. Just do bisection method first. Okay, so is there any question on it? No. Okay, so this is the fourth question. It's a bound for the number of iterations needed to achieve an approximation with accuracy to the solution lying in the interval in bisection method is. So you know how to deal with it? The question, what the questions is saying, bound for number of iterations needed to achieve. Yeah. So they are giving some math like accuracy and okay, so they are saying us to find the number of iterations needed to achieve this much accuracy. Like, what do you mean by accuracy? Like, the difference between the actual root and the approximate root should be less than 10 to the power minus 5. Okay. So there is direct formula for this. Okay. I think so in this book. This one. Error after n iterations should be less than. Okay. This formula you should try to learn where it. Have you seen the lectures? I think there is. He has
Yeah.
defined it. Okay. So you can use this formula and okay, we try to use it maybe. Okay, so what it says, what is the question we have is, so we have x cube minus x minus 1 is equal to 0. Oh, okay. So what is the formula? Formula is this one. So error after an iteration should be less than mod b minus a by 2 to the power n. So what is the value of b here? B is 2 and a is 1, right? And b is 2. It's just 1 by 2 to the power n. What should be the value of n now? What is the bound? Is it right? Okay, so 2 to the power n is lesser than 10 to the power 5. So how do I log base 10? Just n log base 10. What is this value? Can you find out it? Just find out this value. What should be the answer of it? 5 log base tan 2. So there is no use of function you can see in it.
So 16.6.
What is that?
16.6.
Are you sure?
Yeah, log 2 base 10. It's log 2
Okay, so
base.
5 divided by log base tan
Yeah,
2.
yeah,
It is 16.6.
yeah, 16.609.
Oh, is it the right thing? Hmm. Wait a second, I just check it once. Log base tan 2. 0.31. Wait a second. 5 divided by 0.3. 16.66. Yeah. So here is no the bound for what is the so there is no bound here. I think this is some problem. Bound for number of iterations needed to achieve an approximation with accuracy to the solution lying in the interval in bisection method is. Mhm. But this is the formula we have. Error after iterations is less than.
So here we are finding only one value, but bound means bound for number of iterations. So if we tell the number of iterations, okay, correct, no, sir, that is correct, no, sir. It is like up to 16 iterations we may have to do to get this
Mm-hmm.
accuracy of 10 power minus 5.
Yeah, yeah, yeah. Okay.
But the answer is okay, close 9, 11, 8, and 14 only is available.
But 16, like
But
you have to select the bound greater than equal to 16, right? Strictly
correct.
greater than 16. So there is some issues with the answers, I think.
Okay, okay.
Okay, so 16.66, what should be the bound then? Number of iterations should be less than 6, 7. Okay, 17 maybe, strictly.
Yeah,
Yeah,
correct.
okay. So it may be because iterations can't be, so it should be less than 17. 17 should be the right, I think. Greater than equal to 17 will be any bound will work. Okay, so any bound greater than. All right. But you should remember this formula, okay? Now, okay, so I think this is done. I think I should go with some another method. Okay, so next method after bisection will come is the second method I should go with. Okay. So what are the drawbacks of bisection method? I think I have discussed it. That most other root finding methods require a starting value, lacking this may fail. Okay. Okay, so what is another drawback other than f to be continuous? Firstly, f should be continuous, otherwise the bisection method may not work. Okay, and if the function is not given explicitly, uh, yeah, so function should be given explicitly, otherwise there is some problem, right? Do you know what is the meaning of this statement? It should work like, so we have function like e to the power x, x e to the power x, like that. So they should work. But if it is not given explicitly, then bisection method may not work because you will be not be able to find the roots, find the value of the function at some point. Next method is second method. Have you heard this second method in the lectures?
Yes, sir. Yes, sir. But please just give a brief idea.
Oh, okay, okay, sure. So we are given in the second method. So we just start with any 2 points, okay? First 2 points, say x naught and x1. You can see here x naught x1, and on the of course on the curve, like a curve of the function, we just take the value of the function at 2 points and just pass a line through them and see where it cuts off on the x-axis, which is cutting over on say x2 here. And you can see that from the similar, okay, so they are using the similar triangle properties to get this relation from this. So how do you get this relation? X1 minus x2 by f of x1. So it is the smaller triangle and the bigger one. So you just use the similar triangles property to get this relation. And from this you can find the value of x2. Okay. So this is the expression. All right. Like this you do with next iterations and next, and then you get this equation. So graphical representation is just like this, that you start with 2 points, just pass a line from them, and where it cuts on the x-axis, then you just take that point. Okay, and so x2 will be that one. X2 is given by this way. Okay, so so the next, how do you find the next root? Graphically, can you explain me? So here is the x2. So this is function extending for this, right? So you start with f of x1, f of x2, and you just pass a line through them maybe. Okay, so it's like this. So you are getting this one, x3. Like this, you proceed further and you get to closer and closer to the root. Okay, it's just easy.
Okay, clear. Yeah.
Yeah, so it's just easy. You have to use this formula, okay? And what more it says? Yes, so there is a condition in this method that if f of x naught, absolute value of f of x naught is less than absolute value of f of x1, then you have to swap x naught with x1. This is the first condition, otherwise you don't need to. So here the function value at x naught is greater than the function value at x1. Okay, and so
Sir,
you
can you
need to
repeat
swap.
again? F of x naught is less than.
Yeah,
Okay.
absolute value of f of x naught should be, if it is the case that absolute value of f of x naught is less than absolute value of f of x1, then you have to interchange x1 and x naught.
Okay. Okay. Okay.
You know what's the meaning of swapping? You know that, I think,
Yeah. Yeah.
in the code. Okay, so and until you go with some tolerance value like this, whatever the value function at the first iteration point, second iteration point, or like that. Okay, so yeah, of course you need to choose x naught x1 closer to the root, otherwise the method may fail, I think. Yeah. Okay, so what is the question now? For finding the root of cos x equals 0 by second method, which of the following choice would not be appropriate? Okay, so it's just a basic conceptual, like I just say that you need to start the initial guesses around the zero of the function. So where is cos x 0? Pi by 2, 3 pi by 2, 5 pi by 2, right? So which one should not be correct? Pi by 4 and pi, are they too far from the root? So cos x is 0, right? It's pi by 2. If I'm taking positive, right? And pi by 4 and pi. Okay, so okay, let's see. So pi by 4 is less than pi by 2 and pi is greater than pi by 2. Pi by 4 and 3 pi by 4. So it's like 4 pi. It's like, what is this? 3 pi by 4 is quite far. I think pi by 3 and 3 pi by 4. Mhm. So which value should not work? Initial guesses would not be appropriate. So pi by 2 minus pi by 2 and pi by 2 are just directly giving the roots. So it's not good, right? It's not good. We can't take this initial guess which takes the root. Pi by 4 and 3 pi by 4, pi by 4 and pi. And it is good choice because it's just near to the 1 pi by 2 and it will approach to pi by 2, I think. But I think 3 pi by 4 and these 3 pi by 4 is quite far to go. Is it? So yeah, so only I think the okay, so pi by 3 and 3 pi by 4 are a good choice, and pi by 4 and 3 pi by 4 is also maybe, but it may take some time, but it should converge, I think. Yeah.
So can we just show that graphically to understand, like it will be easy?
Yeah. Okay, let me draw a graph of it. Okay, so what is the graph of cos pi by 2? Cos x. It's like this. Okay, 0, 1, pi by 2, 3 pi by 2, 5 pi by 2. Is it?
Yeah,
Mm.
yeah,
Okay, so where is the value pi by 4? Is
yeah.
it
Between
here?
0 and pi by 2. Yeah,
And where is the value 3 pi by 4? Pi is here. Where is 3 pi by 4? Okay, let me see. It's 135 degree between 90 and 270, right?
yeah.
Mm. Okay, somewhere here, maybe 3 pi by 4. And where pi by 3 is, it's 60 degree. So it's just in between pi by 4 and pi by 2. Pi by 3. So you need to approach to pi by 2 root, okay? So how would you approach it? Which one is the good way? You need to take the closer value. So pi and pi by 4 are good, right? And pi by 4 and 3 pi and pi by 4. Okay, wait a second. Pi by, yeah, it's good. First is a good choice. Pi by 4 and 3 pi by 4. It becomes quite far. Pi by 3 and 3 pi by 4 also quite far. Okay. Mhm.
So compared to that, this pi and pi by 4 will be
I
more
think
far.
these should work, except C, all should work.
Okay.
And it may take like some more iterations. You just try with them. Okay.
Yeah, minus pi by 2 will come in the other side, negative side of it.
Yeah, minus pi by 2. Yeah. But yeah, these are just the roots. Cos pi by 2 is 0. We can't choose a value which is just the root. It's false. We can't do that.
Okay.
There is a condition
Now
right
we
here.
are telling that which of the roots will not be the initial. For initial guessing, it should be very close. So we are
For
trying to
initial
select the.
guess, we can't take exactly the root value.
Correct. Okay. Okay. I got it. Yeah.
So C should not be the C must not be
Okay.
the
Okay.
case.
Okay. Okay.
For other values, you can just try and check. But yeah, they should work. Mm, okay. And what about question number 8? Section second method formula for finding the cube root of a real number from the equation is. So you can just try it. Okay, let's see. X cube minus R is 0. So we have a function here. We have a, so if someone says you like to find the quadratic root of a, okay, square root of a number, fourth root of a number, you can do by second method. Just use this. Okay, so what is the equation we are having? X cube minus R is equal to 0. Okay, so what is the value of f of x here? What is the second formula, second method formula? Do you remember that?
X1 minus x2 divided by f of x1.
Okay, xn plus 1, the general one. Xn minus
Okay. Okay.
is, if I'm right, I'm not sure. Is it that?
Yeah. 1 second. Yeah.
Wait a second.
No,
See, it's
No, I
not
think it is.
that. Yeah,
F of x should be in the
it should be
denominator.
reverse, right? Because
F of x
okay.
should be in the denominator.
Hmm, okay. Now it's fine. All right. So, okay. So now you can find out what is the value of f of x and you know that. So you just substitute in it xn minus r f of xn. Okay. So here we have xn minus xn cube minus r. So can you open a cube minus b cube? You know that? Is it that? Is it right? Okay, just multiply this on the right side, xn cube plus xn. Is it right? Okay, so what's the answer? What's the answer now? Tell me. I think C is the right or? Oh, okay. Plus R. Why they are written 2? Okay, I think we have to simplify more it. It's just, no. This is xn, xn minus 1. You can take out, no, common. So answer should be this, xn. So this should be the answer. I think this should two should not come here. Otherwise, it's right. So it's easy, right? So like this, you can find out x square minus r equals 0, x4 minus r equals 0. Find there may be some expressions based on that. You can try this. So of course you need to start with some choices x0 and x1 near to the root and then you proceed. But it's they are saying for to find simplify this expression only in this case. So it is very easy question. Okay, the next one. Use the second method. Okay, so second method don't have much questions. We can proceed to another method. Okay, okay. So what's the problem with the second method is that sometimes like if you choose to select these type of values x0 x1 for this type of function and x2 is there, then you see that the value it will never be close to the root in coming iterations. It will fly off. If you see here x2 is this one, and you can see that. Okay, so x1 and wait a second. So x0 x1 x2, it is x2 is not closer to the root anyway. X2 should come closer to the root, right? So you have to choose the line between them. So if you select this line or okay, depends on. So f of x2 is you have to select x1 or x0 in this case. And here you should select the any of them. Okay. So but the reason is okay, I just give this.
Looks
Yeah,
like
the only
x1 will
do
be
you
bit.
understand this graph?
Yeah, looks like x1 will be closer if you are drawing connecting x2 and x1. That and
Mm-hmm.
extrapolating, it will end up close to root. Rather than x1 to x0, it will go away from the root.
Yes. So it will go away definitely. You need to rectify it. So how do you
So,
rectify it? You can just make sure that the root lies between two starting points, okay?
mhm.
And that's what false position method says you. So you have to make sure that these x0 and x1 bracket a root. All right. Like in the bisection method. So it's false position method is nothing but the combination of bisection method and second method. So we apply bisection method and then second method. That is false position method. And the value of this should be same. So we tried something with the second method. Okay, now. So what is the algorithm says that if you have to determine a root of function given two values that bracket a root, like fx0 and fx1 are of opposite sign, then you find out the value of x2. It's not saying that you apply you just say that x2 is x1 plus x0 by 2. It's not saying that. It's saying the value is given by second formula, okay? The only difference is this. And you have to check the value of f at x2. If that happens again, f of x2 is f of x0 is less than 0, then you continue in the same way to find x3 and so on. So it's like the bisection method, but value of the first iteration, second iteration, all are coming from second method. All right.
So that x2, that is not like you have removed it, no? Like finding x2 is from x1 and x0. That
Yes.
x2 value, okay. We have to okay. We have to
Like in the second method, how you find the x2. That's it.
okay.
Do you remember that? I can go back
Yeah, 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 yeah. Okay.
by
So
this
that is
formula.
okay. Okay.
So it's just an easy thing. So to avoid this, to make sure that the root lies between our starting values, they just use bisection method with second method, nothing else.
So your bisection, whether it is coming in loops or only second method is there, no? Bisection method.
Bisection, okay, so one property is from bisection method, that bracket a root and f of x naught and fx1 are of opposite sign.
Okay, okay. So
This
so that
property
from
bisection
there.
method uses,
Okay,
right?
so it should be one is plus,
It's
another one
not
is minus.
bisection method, yeah.
Okay, okay. Only the property we are taking. Okay.
Only the property, yeah. Okay, so here we were, false position method. Okay, so using method of false position, what is the solution accurate within 10 to the power minus 4 for the problem on the interval? Use endpoints as initial guess. Okay, just try this one. Let's start. So we have, so 10th question is that method of all right. So what is the function value? X cube plus 3x square minus 1 is equal to 0. So tell me how to start. So what is the value of x naught? Can you check whether what is the value of f of x naught?
-3 and -2. Okay.
Yeah, tell me. Is this positive?
It's -1,
F of minus 3 is what?
-1.
Yes, and f of minus 2?
It is 3.
It's 3.
Yeah.
Okay, so we can apply bisection for false position method, right? In this case, it's less than 0 and greater than 0.
Yeah. So
So
it
we
is
are
that type.
sure that root lies here in between, right?
Yeah.
So how do we find the root? How do we find the root? Next root?
Second
x1
method.
minus f of x1 and x1 minus x naught. Is it right?
X naught minus x1, no? Like.
Yeah, it will cancel out my
Okay.
negatives.
Okay. The minus minus bottom on top it will cancel. Okay.
So tell me what is the value of x2 now? Just solve it. Tell me. So this is given by second method basically. It comes from. Wait a second. Found out.
Value 2.75
What is the value?
minus 2.75.
Are you sure it's right? Okay. So x2 is minus 2.75. Okay. So
Yeah.
what this says is, what is the
Or
solution accurate to for the problem? Okay. So what does it mean? Like it says that accurate within 10 to the power minus 4. It means that the absolute difference between last two iterations should be less than 10 to the power minus 4. Okay. So you try to continue it again and again. Like, okay, what is x3? Okay, just check. What I have to check now? Can anybody tell me? Should I check this thing first? Tell me which is true. I can proceed in that interval. X0, x2, or x1, x2. Tell me. So you have calculated the value f of x0, f of x1. What is the value of f at x2?
point 0.8907.
Okay. What is the
0.8907.
value of f of x2?
0.8907.
Okay. 0.8907. And just calculate these. This is true or this is true.
Should be with the
First one,
Yes, yes. First one is true.
yeah.
Okay. Okay, so where the root lies in between x0 and x2, you can proceed in that way. How do you get x3?
so both are less than 0.
What?
Both are less than 0. F of x0 is minus 1.
Both are less than 0, is it?
Yeah, yeah, that's what. Because f of x0 is minus 1.
Okay.
Once again, we are okay. X1 and x2. X1
I
and
think you
x2.
should check once again. I don't think so. Both are should be.
Okay, okay. The second one is not the one. X1 is 3 plus. Yeah, it's a mistake from my side. Yeah.
Okay. So you just try this one.
So it is
So
between.
I am taking x0 1. So you just take this. All right. And you try to calculate x3, and okay, you just don't need to calculate here. You can do it anyways. So what is this value x3? Whatever you get, you just try to find out the it is saying that accuracy, what is about accurate within 10 to the power minus 4. So okay, so either they says that mod f of x3 should be less than 10 to the power minus 4. Okay, it's not like this. I think so. Yeah, they are saying that x3 minus x2 should be less than 10 to the power minus 4. The difference between the last two iterations or whatever. If it is not lesser than 10 to the power minus 4, just continue it again and again until you reach that point. All right? And whatever is that value, x4, x5, x6, anyone. That would be your solution. That would be your answer. Do you understand this?
Yeah, it should be very close to 0. So what we are saying is that up to say 0.000, whatever may be the numerical value, we
Yeah.
have to continue.
Yes. Whatever.
Yeah.
Okay. Now I can start with another method. Okay. So we do have another method, which is Newton-Raphson method, which is a good one, which is most popular. Okay, so in this method, you can see from the graph that you are given 2 points, x0 and x1 again, okay, which are closer to the root. This is the root of the function, of course. And you have the value of function at x0 and x1. So you just try to use the formula which says that the angle which the curve intersect on x-axis, that is theta angle. By theta angle it intersects. So tan theta is f dash x0 divided by, okay, so tan theta is just the slope, so it should be f dash f prime x0, which is same as fx0 upon x0 minus x1 by the formula of tangent. And just you interchange it because f prime x0, just go there and you just try to find out the value of x1 using this. Do you understand this? This is an easy way. Okay. So what similarity you notice between second method and Newton-Raphson method? What is the similarity? You don't know? Okay. So this f prime x naught is basically, this prime fx naught is basically replaced by this one. Do you remember that?
Yeah, here it is. Okay.
So in second method, you are basically just using the approximation of first derivative at some point.
Clear. Yeah.
And here you are using exact value of the fraction, exact value of the derivative of function, which is good enough. But if you are given that function which is not differentiable, then Newton-Raphson method is not good because you are not able to find out the derivative of function at that point. So in that case, use second method, false position method would be good enough.
So given function should be differentiable.
Yes,
Yeah, to use Newton's law. Yeah,
at that point it should
at
be.
that point. Yeah.
But yeah, iterations may go around, but it should be differentiable, yeah, in that interval, whatever you are looking for. Okay, so it's the formula, and but you will see that in the lectures, I think they have shown that the order of convergence. Do you heard about it? The order of convergence of a method. Newton-Raphson method converges with second order. So it has a high order of convergence than other methods. Anyway, let's go on some questions. So the root of the equation is found by utilizing Newton-Raphson method. The underlying initial guess of the root is this. The angle the line tangent to function makes at x equal 3 is this. With respect to x-axis, the next estimate of the root must lie nearly is. So do you understand the question? Yes.
So they have given the function itself, value itself directly, like x03, f of 3 is 5.
Yeah,
Angle
and one thing you should notice is that in the Newton-Raphson method, you only have one starting point. There are
okay.
no two starting
Two
points
start.
like in second method. Do you remember? In second method, you have two starting values. You give two values, input values, but in this method, you give only one value. Okay.
One value. Yeah. Anyway, the angle is also there, theta.
Yeah. So what is theta here?
57.
Because it is making with respect to x-axis. But if it says that it is making with respect to y-axis, then what you need to do? Like this is theta. Maybe I don't. Then you have to use 90 minus theta to come over here.
Okay, okay.
It's just easy. Okay, so tell me how to do this. What is the value of x1? You can easily solve it. So what is the formula? X naught is 3, f of x naught is 5, and you have and tan 57 degree. Calculate it. What is this value? And calculate x1 is equal to, what is the value x naught minus? Is it right? Just solve it and tell me what is the answer.
So whether that x equation is x naught minus x1 equal to f of x naught by tan theta.
Yeah.
So we have written other way, no? X naught equal to x1 minus, or okay. Okay, okay, correct, clear. Clear.
Yeah. So then what is the value of it? Tell me.
Yeah.
Tan 57 equal to 0.4847
Okay.
and x1 equal to minus 7.315.
7.315. Is it the right answer? No. Just check once again. I think there is some problem.
So it is minus 0.247. Minus 0.247 because 1.539 is the one. Yeah, minus.
I think it should be 0.247, I think.
Yeah, minus. One second. Okay.
Just check once again.
Yeah. 1 second.
Minus 0 point.
Yeah, just 1 second.
Just check.
Minus 3.247. Minus 2.47 only it is coming. Another 0 it is not there because 5 divided by tan 57 is 1.539 in degrees if you are taking tan 57. Then 5 divided by 1.539, that is 3.247. So 3 minus 3.247 is minus 0.247.
minus 0.247, right?
Yeah, that is coming correctly. Cross check.
Okay, so B should be right. You can check it, I think.
Yeah, that
But
is.
concept should be clear first.
Yeah, yeah.
Okay, so we are at ninth question now. Using Newton methods to approximate to within 10 to the power the value of x that produces a point on the graph that is closest to 1, 0. Yes. So, do you understand this question? You have to find a point on this graph which is closest to 1, 0. So, which point seems to be closest? This one? Whatever. So, what you need to find, how do you define a function here? Which function you need to find the root of? Do you know that? Tell me.
So y equal to x square is the function.
Yes. It's not the function. If you find
Is
out
that
the
it?
root of x square equals 0, then it doesn't make sense. You need to find out the point on the graph that is closest to 1, 0. So you need to make your own function.
Okay.
So you need to minimize the distance between, say, any point on this graph and 1, 0, right? So what is the distance function here? And minimizing the distance function, distance should be 0, right? But it will never be. So how to define it? Can anybody tell me? What is the function? Okay. So distance function is dx. What is this? How do you define it? X minus 1 is square plus x square to the square. Is it right? And you just try to take d square and use this to find out the function as x is equal to 0. Find x such that. Is it right? Can you do that? Where Sx is. Okay. Tell me how to find out. Just start with first initial guess. They have said R naught is 1. So x naught is 1. And you just try to find x1, which is x naught minus s of x naught by s dash x naught. Okay. And here you go. So what is s dash x naught, which is just 2x minus 1 plus 4x cube. And at 1, it should be 4, right? And you know what is s of x naught, which is basically 1 at 1. So x1 is 1 minus 1 by 4. Okay. Like this, you continue. You try to find out x2. x2 is x1 minus f of s of x1 by s dash x1. You continue like that till you reach the point where something like xn minus 1 should be less than 10 to the power minus 4. Then you select the value xn. That should be your answer. Do you get it?
Yeah, similar to that earlier one of the problem what we did. So that should
It's
be 10
similar,
power
but yeah,
next.
there is no explicit function given to us in this case.
Yeah, yeah. So this are how it has come. This distance function is a general terminology like general equation.
It's just a Euclidean distance, you know that?
Okay, okay.
Don't you know the different just how to find the distance between 2 points on a 2D plane?
It will be better to explain. Maybe it is very simple.
Okay, so
Very
here is the point x and x square and 1 comma 0. You have to
okay.
find the distance between you try to find out the distance between 2 points, right? 5 2 and 1 0. How do you find the distance between 2 points in 2D plane? You know this, right? So the formula is to find the distance between AB and CD. It's
Okay,
just this one, A minus C square plus B minus D.
okay, okay.
Okay, it's the basic. Like this, so you understand how do I make it this function, right?
So it is between one function we have taken it as x square.
Mm-hmm.
Sorry, this 2 points. We have seen is one is with respect to one. That is in the equation graphical plot. What you have shown first is y equal to x square, and that is one part. Then x equal to one.
Yeah.
So the distance between the two, you arrived at this equation.
Mm.
So can we go to that graph just for understanding?
Yes, yes. So you have this type of graph, right?
Yeah, yeah.
And you have any arbitrary point on this graph is like x square, right? And you
Okay,
have 1 0. You need to find the point which is very close to 1 0 on this graph. So the distance should be minimum. This
okay,
distance dx.
okay, okay.
Okay, so you need to find that point actually, and you will find out it maybe in this. Yeah, it should lie between 0 and 1, I think. So here are some options which guarantee that should lie between 0 and 1. Okay. So should I go next method? Okay, so there is one question which was also. So Newton-Raphson method is not a bracketing method, it's an open method. Open means it doesn't bracket but starts with some starting point. Yeah, it's a just random math initialization we have to do, and graphical it's. So we do have another method which is called as fixed point iteration method after this. You have heard of it in lectures? What is fixed point iteration method? Do you know this? So if you have a function, if you have an equation f of x equals 0, you just try to write like this. X is equal to g of x. Okay. And like I just explained with some examples. So f of x is given to you like this. So you need to find the root of f of x. You just start with some starting guess. X naught is equal to 4. You write this function in this form. X is equal to gx. You can write this. So you just start with x naught something. X1 you try to find out using this relation. Xn plus 1 is gxn. You try to write this. X is equal to gx. And you replace by this. Xn plus 1 is gxn. That's it. You start with some point x naught. It's not a big deal. And okay. So here in this question, it says that the sequence defined by Pn is Gpn minus 1. Then for which G, the fixed point theorem gives to guarantee the sequence converges to unique fixed point. So you need to remember that for the convergence of the sequence to a fixed point, this modulus of gx in this interval should be less than 1, strictly less than 1. Okay? Okay, so modulus of g dash x, g prime x. So you just need to check this thing. Can you check it?
So for all the functions, we need to check g dash
Yeah,
x with x1 to 2.
yes. So if that is the case, then we are sure that the fixed point method converges to a fixed point, unique fixed point. There is a proof of it, you can see that. But if it is not the case, then it will not converge.
Sir, for just can you explain at least one step? Like in this, gx is there for first equation. G of x also we can find that. Then we apply
Mhm.
this point as 1. Correct, sir? First one we have to apply gs1 and gs2.
Yes.
We have
Okay,
to set
I explain it or okay.
just for beginning itself, beginning only, like
Okay.
how we have
Okay,
to
okay,
proceed.
okay, okay. Yeah. So G prime 1 is what? G prime x is what? Is 1 minus 3x square
For first
minus
equation, 1 minus
8x.
3x square minus 8x. Yeah.
Yeah. So what type of function it is in the interval 1, 2? Is it a decreasing function or it is an increasing function? G dash x. It is I think it is a decreasing function, right?
Yeah.
So you just try to calculate the value of G prime at 1 and it is minus 8, and G prime at 2 it is just minus 12 and minus 11 minus 16. It is just it is negative, right? It is much negative. So G
So
prime values,
G of 1 also it is negative.
and you can
Minus
easily
10.
check, yeah,
Yeah,
G
minus
prime
10.
of 2 is greater than 1.
Okay. That is correct. Yeah.
So it's not good. So first function is not right.
Okay.
Second function you can check with, you try to check with the values x between 1 and 2. And if you get that, you need to prove that, of course, G prime x is less than 1. You can do anyway, graphically, anything, or taking the double derivative.
Okay.
Okay. So, yeah. Do we have any other question now? Don't think so. Okay, I can explain more about this fixed point iteration method. So you see that so I give you a function and tell me what are the rearrangements of that possibly. Wait a second. So this function f of x is x square minus 2x minus 3 is equal to 0. X square minus 2x minus 3 is equal to 0. So what is the value of gx? What should be the possible values? Tell me. What should be the gx value?
Same function can be taken as gx.
Yes. So x square minus 2x minus 3 is equal to 0. How do you find out separate x from it? So x square is 2x plus 3. X is basically x square minus 3 by 2. Is it right? So what is gx? Okay, correct.
Yeah. Yeah. That is
And g
correct.
dash x is 2. G dash x is x, right? So mod g dash x should be less than 1 for convergence. So we have in interval -1, 3. Okay, so what is the interval? Start with something. Anyway, so you just take an interval in it, like 1 to 2. So if you take this interval, then it will not converge, right? So it should be less than, so it should be strictly like, okay. So it is convergent in this interval, -1, 0, open. Because mod g dash x is less than 1 in this. Okay? -1, 1, basically.
So any value below 0, it will be negative. No, sir. So minus
Yeah.
1, yeah, -1 come out.
So
Okay.
absolute value should be less than 1. Just like in this relation, I just go with that. So you can see the proof of it here, that this thing should be there around the root r, and this should hold. Modulus value of g dash prime should be less than 1 over that interval. All right. So there are other possible recombinations of g as well. So what is another g? What is the another value of g? Do you know? So again, I write x square minus 2x minus 3. Okay. So what is the g now?
Square root 2x
X.
plus
Yes.
square root 2x plus 3.
Yeah. Any other g? G1 x c. Any other combination you see, like, or not? Okay, maybe this one, x minus 2 minus 3. Is it right? This is G3, G2. All right. So you just try to check whether it will converge to a root for some starting values. So if you start with something like 4, of course, then G prime inside like the interval you are getting in 3 to 5, say, then it should be the G prime value for any interval. Depends. Just check it out. All right. So we are done with it, and let me know if you have any questions now. Yes, I'm here for questions. So why people reduced to 13 now? The first lecture there was 20. Have you done the assignment 3? Yes. Or not done anything?
No, sir.
Why you have not done any question of assignment 3?
Almost 7 over for 3 1 plus that.
Okay. Is it easy or tough? Let me see the solution. I have solutions. I think it's easy. Like, I just say that these types of questions are there, whatever I have told today.
Yeah, and one small doubts are actually like this NPTEL guidelines says that we should not use any calculator, which means we should try to practice with the on-screen calculator. Is it like that?
Oh, so physical calculator is not allowed?
Yeah, this exam registration option, there was some guidelines in which that is there, like FAQs. So they have put
Okay,
like
so you need to practice online calculator maybe.
there will be an online calculator available. That is
Yeah.
the
So I've told you in the question papers, you should know that there are like recall based questions are very easy to solve. You don't need to use calculators. This is just conceptual. So 10 questions, I think in one set there will be 50 questions, right?
yeah 50.
50 questions and yeah, 10 questions. I think it should be from recall. Yeah. 10 should be from recall, 15 from assignment. 15 on, wait a second, I have something. Maybe. Okay. Yeah, 10 questions should be from recall, and I think 15 from assignment, and rest 25 are open.
Okay, so open in the sense like how it will be like
What?
open type questions means like it will not be either assignment or recall. We have to like
Yeah,
yeah. It
you
will be
need to
totally
think about open questions are maybe from, but they require more than assignment.
okay.
But assignment questions are easy to solve. Just need to practice. Assignment recall.
We should practice that use of online calculators also if number of iterations are more. Because when we
Yeah,
are
so if they
there
give like
only
questions, lengthy questions, maybe they are, but it depends. Like all of you are doing it, and it should not be a problem if you do attempt a less. So it will be relative, right? Or it is absolute grading. How they grade?
minimum score is required. That is the point.
Oh, okay. So is this course are you doing for certificate, or is it running in your university?
For me, it is like I'm already working, so it is like an additional part I registered for my PhD coursework. So this is what for that.
Okay, so you are a PhD student?
Yeah, I'm working in ISRO. I joined for PhD in IIST.
IIST or IISc?
IIST, Indian Institute of Space Science and Technology.
Okay. You're working. Great. So you are in which year? Second.
No, first I just joined.
Okay.
Coursework since
So
we are
you are
working.
working and you are doing PhD. It's a part-time kind of.
Exactly. Yeah, working in office 9 to 5. Then after that, coursework we are doing through NPTEL.
Oh, okay. Good. Anyone has any query other than Shravan? So next assignment is based on root finding or what? And that is to see that. So next assignment is based on matrices. Just go through the lectures of matrix analysis and all. LU decompositions, Cholesky factorizations and all. Go with
Next week,
that.
yeah, next week is yet to be loaded. I think that is not yet loaded.
What are you saying?
Week 4 lectures are yet to be live. I think.
Okay. They are not live yet.
It is not there.
Okay. So when are your exams? In April or?
It is in April 28th. I think April 28th.
April 28th. Okay. So how are you getting marks in assignment? Is it good or bad?
Only that few questions where I had a
Yeah.
problem that only I raised at the beginning. Probably that I will share with you to clarify.
Yes,
Because I
share
just want
with
to know
me.
where I made the mistake.
Yeah.
Otherwise, the absolute error and the relative error, I think the options itself, if it is wrong, probably I will. You can just guide me out.
They should provide you marks if that is the case.
Yeah.
Yes,
Excuse me, sir.
Subhashish, yeah.
Sir, can you please tell us something about yourself? I mean, what you are pursuing or anything else like
About
that?
me? Oh, okay. I'm a PhD student in IIT Delhi and University of Queensland, Australia. There is a joint program between that. So I'm in the second year of PhD right now, and I'm out of the India. I'm in Australia right now for completion of 1 year of my PhD here. So I've just started here from 1 February. I am here, and I'm working under Professor Mani Mehra. That I think she's the instructor of this course, and Vivek Mehra is her husband. They both are instructors. So I'm a PMR candidate, so just chosen this like for taking the tutorials of this course. Yeah, that's all about me.
Thank you, sir.
So everyone is doing PhD, or what you are doing, Subhashish?
Sir, I am having my integrated MSc B.Ed in Central University of Rajasthan now.
Okay, okay. So you will plan to do PhD later on, maybe.
Yes, sir.
Okay. So maybe you try in abroad or something. Maybe. So have you found out my recorded videos on YouTube? I have uploaded the last 2 weeks videos.
Yes, yes, it has come.
Okay. Maybe I stop now because everyone has done with questions.
Okay, thank you.
Yeah. Thank you. Thank you. Bye. Meet you in the next class.
Sure, bye.
अरे सौम्य सा